Thank you, everybody, for being here. My name is Rich Dione. I am the co-director of the Fusion Studio for Entertainment and Engineering here at Purdue University. We are not in the Martinson Entertainment and Engineering Labs today because I am at the US ITT conference in Columbus, Ohio. So you have a nondescript background, so you don't have to see my hotel room, which would be awkward for everybody. With us today, I'm excited to welcome Ian Hunter. A little bit of his bio here. He comes from a family with a long legacy in the broadcast business and has been involved in various forms of production for nearly 30 years, including extensive work in live events and with professional AV rental production companies. He got a BA in theater production from Brigham Young and an MFA in sound system design from some school in Indiana called Purdue University. I've never really heard of it, but that's I'm sure it's good. Ian's work in the live production sector is extensive and includes both live and recorded entertainment work. He's provided large-scale event production for many national touring live music acts and has designed and mixed over 100 theatrical productions. He has been at the Shalleck Collaborative since June 2005 and has designed facilities, AV systems, and general project management for hundreds of event production and meeting facilities. We're going to talk a little bit about what that means and some of the work he's done. I think we're going to look specifically at the Nimoy Theater. Is that right? Is that the name of it? Sure. We were talking back and forth about a venue to pick, and I said, well, I'm a geek and I like Star Trek, so let's do that one. It's fairly informal. He's going to talk about that work, what he does, that project. Feel free to throw questions in the chat, and I'll try to insert them in the conversation as we go, and I will probably interrupt him as well. That's way too long an introduction, but thank you, Ian, for being here, and I'm just going to kick it for you and let you start.
Okay, sounds good. Well, thanks everyone for joining us this morning. I'll get the old Zoom button rolling here. So as Rich said, I am employee number 2 or 3 at the Shalleck Collaborative. We are in San Francisco, or technically Berkeley, but San Francisco, if you don't know where that Berkeley is. We've been around for 23 years, and our bar here says we do planning and design of theaters, production systems, and AV. When I'm on the elevator, I tell people we design gathering spaces because we do things more than theaters. We do higher education rooms, we do sports facilities, we do city council chambers, anywhere museums, anywhere that people get together. You know, all of the same tenets that apply to good theater design apply to those spaces as well. So I thought we'd talk a little bit about what it is that we do. Some people don't quite understand what a theater consultant does. So if I can distill it down to a few bullet points, really we are a translator. We are specialists in a whole bunch of different things, and we are kind of at the core of the building design for performing arts. So translator of what? Well, we know a lot about architecture. We know a lot about engineering, electrical, mechanical, structural, that sort of thing. We know a lot about theater because that's mostly where all of us came from. And we know a lot about construction and how you build something. So we're kind of like, I don't know if unicorn is the right word, but like we're kind of that person in the middle of all those trades. Every project has an architect and a team of engineers and a user and a construction team. None of those people really speak the same language, as it turns out. So our role really at the end of the day is to translate between everyone. When the user says, hey, I'm gonna do shows that have 40 line sets, and I want a counter rating system. The structural engineer goes, rad, what's that? And so we kind of say, hey, well, we need a giant fly tower and we need this much structural load on it. And then the architect goes, cool, you're making this giant box. What am I gonna put on the outside of it, on the inside of it? A mechanical person might say, how do we make air conditioning work in that space? So really that translator thing is kind of the core of what it is that really a theater consultant does. Past that, we tend to try and interject kind of new trends and new ideas into theater consulting. If you've been in any theaters that are very old or very new, you've probably noticed that there's pretty significant differences between not just the production technology, you know, the lighting and sound and rigging and all that stuff, that changes frequently with new technologies coming out, but the actual built environment changes quite a bit, and those environments are heavily impacted by building codes and ADA and just what people feel is comfortable. if you've ever gone into an older theater house and sat up in the balcony, which were and still are the cheap seats, the row to row depth is very narrow. And if you're over 5'5", your knees are probably hitting the row in front of you. And it's not terribly comfortable. As it turns out, people like to be comfortable when they go to see a show. It's a new concept, I don't know. So that's something that's really impacted a lot, making the rows bigger. We're all growing slightly more rotund, it seems, so making the seats wider. People don't like the coach seat, all the way through that 4-hour show that you're putting on. So, these sorts of things really start to affect the built environment in the space, and when you go to see a show, we want to encourage people to come. We want to make them comfortable. We want to make it so that they don't sit there and go, God, this I can't even focus on the show because it's hot and stuffy and I can't see and I'm uncomfortable and this chair is hard and my butt fell asleep and my knees are cramped up. Like, none of those things are great for encouraging people to come to live entertainment venues, which is what I think we're all trying to do here. So that's kind of our MO. How we go about that is an architectural term called programming, not computer programming. We're not writing code about this, but it's an architectural term that means what are you going to do here? What is the foundation of this facility? And some of those questions might be, what kind of shows are you going to produce? Are you going to be a 10,000 seat rock and roll venue? Are you going to be an intimate 99 seat venue that's going to produce new works for $5 tickets? What is it that you're going to do in here? Because every single thing you talk about, again, informs that built environment. We also have to interject the budget. The reality of paying for things is very, very important in our life, and I spend most of my time figuring out how to make the client's wishes align with the client's budget. That's a hard thing to do. And then who's going to operate it? If you're at a high school that doesn't really have a TD, maybe a fly tower, traditional counterweight fly tower is not going to be the best solution for you because they're kind of dangerous. Maybe a tension grid system. Maybe you have no technical people, but you have a lot of great computer graphics people, and maybe a projected scenery is a little easier to deal with than someone painting drops or renting stuff that has to be rigged. So those sorts of things go into the programming, and think of the programming phase as the foundation of a building, right? If you have a poor foundation, your building is going to fall down. So we very, very much try not to build a building that no one can use, that no one can afford, and that no one wants. Does happen, not by our firm, of course, but it does occasionally come up. So that is generally what it is that we do here. From here, do you want to jump into kind of an investigation of the Nimoy Theater as a project?
Sure. Yeah, I think before we dig deep into that, it's interesting, and maybe only interesting to me because it keeps coming up in my life in the last few days. This idea that there are certain roles in our industry that are all about being translators, right? Like recognizing that no one's going to speak my language. I have to understand theirs. And communicate to this person in their language and this person in their language. And I think that's an under-recognized skill necessity, right? And I think about our shared mentor, Rick Thomas, who will say that of certain students like yourself, that they're really good at like dealing with the people involved, right? And it's sort of this amorphous skill. Maybe later, if we have time, I'd love to hear more about how you felt you developed that skill, and whether that was a specific course you took or whether that was a thing you watched that person and went, oh, that's how to do it. Because I think that's a challenge for educators. I think it's a challenge for students, and potentially for employers and working professionals. Like, how do I go back and develop that skill, or how do I mentor somebody who's working for me to be better at that? Because I do, in my experience, it does kind of all boil down to that, right? The collaboration doesn't work if we can't talk to each other.
That's very true. We can touch on it right now because it's frankly more important than probably anything else we'll talk about today.
That's fair. Yeah.
And I think that I learned that skill in theater production, in live event production, because probably unlike anything else I can equivocate to putting up a show of any kind in usually a very short time frame requires phenomenal communication skills in order to be successful, at least. So I would say the number one place I learned that was just by doing theater. It's all of those skills that you learn from this industry that are applicable to everywhere else. So that's probably my main thing. I would say there are certain technical things you just have to learn, and Rick encouraged me to take several classes at Purdue that were outside of the theater department. One was electrical engineering, just to get an understanding of how does power work. Where does it come from? How do transformers work? What are the different voltages? All that sort of stuff. So I took a course in the electrical engineering department that was hugely helpful. I still use the information from that today, because it's not just the outlet on the wall. There's a lot more to it than what comes out the outlet. Same with acoustics. I know Purdue has a lot of good, room acoustic and facility acoustic programs. So taking those, I wish I had taken some architecture classes just to get a core understanding. That was probably the biggest piece I had to learn as we go through this. Because our clients this may surprise you, our clients are not the owners of the building or the operators, they're architects. We're hired by architects to assist them in projects that have theaters in them. So learning that side of it is a trick. The owner of our company, Adam Shalleck, came to this industry from architecture. He actually has a stamp. He's a fellow of the AIA. So you find our industry is full of people either from the architecture side or the production side, and usually most firms have pretty good mix of those people. Our side has 2 of 20 from architecture, and the rest are from production. So maybe we're a little outside.
Fair enough. Yeah. So another interesting question that comes out of that, I see. So I participate in a whole lot of social media groups that sort of support the technical theater educators and technical theater practitioners, and it's probably once a week that I see something come up that the school or the venue or the performing arts center I'm working at, we're looking at upgrades or renovations, and no one's listening to what I'm saying. And then someone will post and say, well, you got to get a theater consultant. And it's interesting to hear you say, well, we're hired by the architect, not by the venue. And maybe this isn't a question you can answer, or maybe there is no good answer to this, but I would be curious, how do you get a consulting firm involved if you're not the architect, if you're the end user and you know that that's a hole?
Yeah, I should say on in that example, we do often get called by the owners to say, hey, we know you do theater, we know you're a theater consultant, we don't know what we don't know, but we know that you might know the answers. So a lot of times we are in a really early, even before kind of programming, to just help users understand kind of concept level design time of what do you want to do, what is that going to mean for architectural engineering, all those other trades, and kind of help them, kind of educate them about the process of going from where you are today to where you want to be. And sometimes if they're like, hey, our rigging system is broken, well, call Sapsis and they'll fix it for you. That's a quick phone call. Sometimes they're like, hey, we need 300 more seats in our theater. We want to add a fly tower or, whatever. Okay, then we can help you. And in those cases, we kind of hook them up with architects that know what they're doing. So it goes both ways, but at the end of the day, in a big project, it's always an architect that's leading the charge, although we may have been there early to kind of help them figure out what they're doing.
Gotcha. Okay, that's helpful. And see, I didn't anticipate having 1,000 questions, but even as we're talking, I'm like, oh, I want to ask this too. I want to save them up for later, but let's jump into the Nimoy Theater, which was a renovation project, right?
Yeah. So this is, as you can see on the screen here, at UCLA. It's just off campus. This previously was a theater that was either owned or operated by the Disney Corporation. So they would use it for, first run screenings and premieres and stuff like that. It had been around for a very long time. It's had a life as a movie house for, I think, since the 20s, if I recall. So this is a before picture, essentially. So very, very traditional, just gentle slope on the seats, very old school movie theater, cool relief on the walls with blacklight murals. I mean, it was all the things you would have seen in, like, you know, the 20s and 30s. And this one had been kind of refreshed and renovated for the movie use. When the operator abandoned it, they or got rid of it, they made an agreement with UCLA to procure the space, and the folks at UCLA, UCLA Presents, I think it's called, which is similar to like what the Hall of Music does. You know, they bring in events. They had several large spaces on campus, but they didn't have anything that was in that 300 seat range, and they didn't really have anything that could be a little less formal and a little more cabaret table style thing, because there's a lot of performances that don't need 1,500 seats or can't sell 1,500 seats. And you know, the price point is lower for those and all this sort of stuff. So that is where it came from. Somewhere along the way, the Nimoy Foundation, Leonard's wife, I believe, runs the foundation at the time, at least. She and UCLA got together and provided the naming rights. So if you are ever in LA, in just outside of UCLA, you can drive by and see this gorgeous, restored, actual neon, you know, marquee and blade sign and everything. The one license we did take, we put LED screens in where the old letterboards would go. So these are actual LED screens, but the rest of it is kind of the original intent. It kind of looked like this before. I think it just used to say Crest, but you know, the same number of letters, so it made it easy to swap it out. So let's get into kind of what we did here. The core idea here was to figure out first what to do with the space, and we came up with several different sketches, and this is kind of part of that programming phase like we talked about. So a lot of times the answer is not really known until people start seeing what options there are, right? So at the very front of it, we'll just start drawing a whole bunch of sketches. We'll just throw out all kinds of different ideas and test them and see if they fit and see if we can get the number of seats, and you know, just generally find out what we can do within the footprint available. So this is kind of one of our very, very first plan views. We start with seating usually just to see what's going to happen. So I'll just walk you through a few of them. I think we did 8 different seating versions, variations on all of them. So let's see, I think we have sections of all these. Let's see if I can kind of get them on the same screen. So plan view, very typical, kind of front facing, slope in the front, steps in the back. One thing we're always very conscious of is sightlines. So pretty much from the very, very start, we will start showing these sightline views. And sightlines, just to sidebar this a little bit, heavily also depend on what you're going to do in here. If this is to be a modern dance venue, we want to see the feet of all the people dancing. You know, so you're going to see a real steep stage, a real steep seating rake, and a very low stage so that everyone can see the floor. In a live music venue or a presentation venue like this, generally around the waist and up is fine. You know, there's not a lot happening on the stage generally, so not as important, but we really start to test that as we move through the different versions. Next up, we said, well, maybe we want to kind of have a little bit different layout where we come up the back, go in on the side, maybe have a smaller stage area. So these are kind of just variations on a theme. You can see these sight lines are not the greatest as we move through there. We said, what if we just had one giant, huge bank of seats all stepped? What would that look like? Well, you know, by the time you're back up here, it's almost like you're in a cave. The sight lines are not great, you know, they're okay. This imagined like a telescopic seating where all of these seats could come out like bleachers so they could have just a flat floor. Maybe the presentation style requires that. They're going to have a lot of banquets or something, fundraisers, and they just need, you know, 6 top tables everywhere. But sometimes they want to put in chairs. So those are some options there. Here's what you could maybe do with that if you had half telescopic and half cabaret style seats. And then here's another variation, you know. So we kind of just test all of these different versions to find out, hey, what's going to stick here? What you want to do? And a lot of times the owner, the client, the operator hasn't really thought through all these things. So they're really good vehicles to just help people understand, you know, what are we going to do here? This is the final version, the as-built version. So you can see it kind of turned out to be kind of a hybrid of all of those really at the end of the day. So we have a fixed step seating back here and then telescopic rows down here. So they got the combo platter of both rake seats and the ability to do flat floor. In section, it looks like this. So here's our fixed rake steep seats. These are all telescopic platforms, so they can be retracted to either have tables on them or deployed to have fixed seats. And then they also said, hey, the stage is kind of small for 300 seats. What if we had a little stage extension? When we have a bigger show, we can put it in. When we have a smaller show, we can take it out and have more chairs. So that's kind of the evolution over, the course of, when was this, from 21. So about 2.5 years between the first set of sketches and the last set of sketches, and a lot of construction and everything. But that kind of gives you an idea of the elevation of the room and how we develop.
I love it. I love two specific things about it. One, it's so allegorical to the set design process, right? Like, we're thinking about the ways in which the actors are going to need to move around and how to tell the story. And there are different ways we can lay out the space to facilitate that. I also just really love that the last version had a big old chunk marked storage. Like there was a solution that provided a benefit that seems to always have to get overlooked for cost purposes.
Yeah.
But here's a big open space we have to have because we have to have these risers above. Let's just put stuff underneath. I love it. Thank you.
There has never been a theater built in the history of theaters that had enough storage. It simply does not exist.
Absolutely true. Absolutely true.
All right, so here's the kind of the final version. I can let's make this bigger. I'm gonna keep switching this. Sorry about that. Yeah, of course. Okay, so this is the final version. You can see the seats. These are deployed now, so these are the telescopic seats. Looks like the stage extension is in currently, so this little chunk here is the deeper stage. We have our line arrays, we have our pipe grid, we have our projector, we have our lights that light up the sidewall murals. These are original. We kept those kind of relief bits, and then we had to redo the mural because the old one just kind of fell apart when we touched it. So it looks pretty much the same, but isn't the exact one.
Was that painted in space, or was that like a vinyl applique? How did you achieve that?
I believe it was a printed applique like you would get from Rose Brand, where they'll print like a drop sort of thing. It is acoustically transparent, so that we don't create giant acoustic problems in there. So I think it's basically like a scrim drop that has fuzz behind it.
Awesome, thanks.
And then it's got black lights on it. It's kind of hard to see in this picture, but it is painted with black light paint. So when you go into black light mode, it gives some like highlights and other stuff, which is very popular back in the day. Okay. This is just some different views of those different options for seating. So you can kind of switch between the three. And yeah, that's the Nimoy Theater. Is there any other deeper dive on any of the technical systems we want to look at, or anything about the process?
I was going to ask, so we talked about, or you've talked about the physicality of the space, but you had mentioned earlier thinking about trends and technologies. What was involved in bringing the lighting, the sound, and the projection systems in 20 minutes or less? What was involved in bringing those up to a more contemporary approach?
Yeah, sure. So we can talk about maybe those in three different versions: rigging, lighting, and AV. We'll start with rigging. In this case, while I'm sure the users would have loved to have anything that moves overhead, we were just constrained by the building. We couldn't go up. There was not budget to build a fly tower or catwalks or any of that sort of stuff. So we did a pipe grid. The pipe grid, it's a little hard to tell in here, but it only exists over an area that can be a flat floor because you have to get up to it on either a ladder or a lift. Access is something that we also think about immediately, because while you could have a motorized batten here to hoist the lights up, it doesn't help you for focus if it's over fixed slope seats or something like that. So figuring out how to get to stuff there and how to access it once it's there is very important. We would always prefer catwalks, of course, because that makes it much easier. It's much safer. There's no lifts or ladders involved. but sometimes you just don't have the room or the budget to do those. So in this case, you'll see it's a pipe grid. There's a fair amount of movers on this, which are, make it easy for refocusing. Those also have about twice as much service requirements as a fixed fixture, so you still need to get up to them because inevitably they break or need service, or something goes wrong with them because there are a whole bunch of tiny motors with a computer. So inevitably something's gonna grab out. So that's kind of how we got to the pipe grid. And this is, by rigging standards, probably the simplest solution there is to overhead, attachment, and very effective so long as you can get to it in a safe manner.
Sure. And well, I was going to ask, and we may or may not have time to dig into some of these details, so go ahead and just sort of hit an overview if you have to, but what kinds of conversations when thinking about, say, a pipe grid happen between you and the user and the engineering team, right? Because something's got to hold up the pipe grid, and you got to know what the pipe grid's holding up, and there's lots of conversations there. Can you talk a little about that?
Sure. Yeah, and especially in a historic building like this, where we were not going to be able to really modify the structure significantly. We could modify it a little, and only insofar as it was necessary to meet current codes and stuff. But there wasn't really any money or space within the building to do significant structural upgrades to hold up heavier rigging. So we kind of know how much pipe grids weigh and how they're attached. And in this project, there was a lot of back and forth between us and the structural engineer to use the existing building structure in a way that could hold up this pipe grid. We're at the edge of the capacity though, so the users have learned, and we've given them a few dedicated heavier capacity rigging points specifically to hold up the loudspeakers. But everything else is on the pipe grid, and it's 25 pounds of lineal foot. And if you exceed that, you're gonna have problems. So,
Wow, that's a really specific and tight parameter, and that's interesting. And so, what are, not to get into all sort of legalese, but what are your responsibilities and liabilities about that? Like, here's the documentation that says what it is, and there's signage that's in the space, and then that's it? Or like, how does that work?
Sure. So we, as a consultant-based company, are not an engineering company. So we do not hold the stamp, and the stamp is really the liability stamp, right? So
Gotcha.
all the liability is on the structural engineering for the most part.
That's good for you guys, right?
Exactly.
Yeah.
However, we of course are the ones that are kind of telling them what we want and how it works. So probably in reality, it's a bit of a shared liability, but we and the structural engineers, and really any engineer worth their salt, always errs on the side of very conservative structural design.
Sure.
If the users choose to come in and hang stuff way more than the pipe grid can hold and it fails, that's kind of on them. We require that you have users who know what they're doing and are professional people. It's same with the fly tower space. If you have a 2,000-pound capacity arbor and you hang a car on it, like, it's probably going to fail.
Right.
Can you hang a car on it? Probably. Is it going to fall? For sure.
Well, and I think that's important for people to know, both from the end user perspective, like, it's on you, right? If you've been told this is what it can do and you decide, it should be able to do more than that, or it did it last time, it's fine, it's going to be fine again, that's on you.
I can see the pipe deflecting, but I'm going to still do this or add more to it.
Right.
There's a lot of ways to get very seriously hurt in a theater, as you are probably aware, and it requires people who know what they're doing. That's not why we don't just let anyone roll into these spaces. Places that don't have someone who knows what they're doing, we pretty much require like a tension grid where you just can't fall.
Yeah.
You can't get really into too much trouble. You can maybe drop a wrench through the slat, but you can't drop a person or a light or anything like that. So you're absolutely right. We spend a lot of time thinking about liability and how to make places very safe for the intended operators, which goes back to that programming level.
Yeah. Thanks for that sidebar.
Totally.
And then I think we were about to talk about maybe lighting and then AV, which
Lighting.
I think are really,
Yeah, so lighting, gosh, what a complete sea change in, I would say it's been the past 10 years or so, and maybe the past 5 years, where LED fixtures have become really, really widely accepted. The first version of the ETC Source 4, for example, was really great, had some drawbacks, was a little people resistant, hesitant, it had a couple of problems. By version 2, they've solved all those, and now version 3 is phenomenal. So it's very rare that we ever run into people that are like, we must have incandescent still. It just doesn't happen. The only time when it does happen is in very, very sensitive acoustic spaces, because every LED light, except for very kind of dimmer ones, have a fan in them. And the fan is variable based on how bright a light and what color of light you're putting out, if it's an RGB style. So if you have a concert hall and you have 300 lights and you turn them all on at full, all of a sudden you're going to hear a shop vac running in the catwalk, and that's a non-starter. So oftentimes in concert halls, at the moment, no one makes a bright enough LED that doesn't have a fan. Someday someone will, probably, but at the moment we're still stuck with incandescent in those spaces. Everywhere else, LED, which is great. The heat load goes down significantly, so way less air conditioning. The power load goes down significantly, so much smaller transformers, much less power draw from the grid. The labor goes down significantly because you're not changing lamps, you're not replacing burnt out gel. It's really easy to create in those spaces. The main difference is the cost of the fixtures went from $400 to $3,000. So
right.
You kind of have to paint the picture of like, yeah, we're saving all this money over here on the building, but we're spending a lot more money on the fixtures. So
Yeah.
that's been something to help cost estimators and those guys understand, like, just we're not really saving a lot of money, we're just moving money from
Sure, we're changing it. Yeah, changing what you're spending it on. Well, exactly. And the distribution changes dramatically, right? Like, because now you're mostly distributing constant power, and that goes a lot further, right? It's not basically 4 fixtures for 20 amps. You can get quite a few more fixtures because they're drawing less, but it's a lot of this more distributed data, I imagine, right?
Yes, we're still, and God bless DMX, we're still we're still stuck on this 1990 US ITT. I mean, like, we're still using that, which is pretty crazy when you think about all of the network-based stuff. We have network to the node, but most all fixtures still take DMX into them. It's some fixtures have kind of come and gone with ArtNet connections, and they just don't seem to stick around. DMX really just seems to be the thing. So, there's just basically like every other system now, it's a data network, and you hang a thing on the end of it that makes the signal you need. True of audio, true of video, true of DMX, true of pretty much anything now. So it's basically a data network that looks like a lighting system, and then a whole bunch of outlets that are fed from breakers that you can turn on and off. But I mean, you can put 9 lights on a 20 amp circuit, for like a regular color source LECO. So that's pretty cool. You can daisy chain them through, saves a lot of money in copper, more flexible.
It does mean you don't have what we used to call dimmer beach anymore, right? Like, so there's no longer this dedicated climate controlled room with racks of dimmers. That's a huge change to how you think about the space, right?
Yeah, it's saved a lot of space, and really, it's hard to overstate the savings in the long-term costs of operating the building. The power, both in electrical power and in power needed for air conditioning, is a quarter or less of what it was, which is in a giant building like, say, Powell Hall, is a huge number over the course of the building's life of 50 years.
Sure. But so when you start talking about environmental impact as well, I mean, your power grid footprint is clearly much smaller. That's kind of huge. You talked about that basically we've got lighting networks and sound networks and video networks. We're going to run out of time. I have 1,000 questions. We're going to run out of time. I'm sorry. And I'll remind everybody, if you have questions yourself, I'll ask your questions before I ask mine. Just throw them in the chat. But I mean, have we swapped out Dimmer Beach for a telecom room that has racks of uh, um, switches and network equipment? Is that sort of what we've done?
Yeah.
Yeah, basically.
We switched out Dimmer Beach and Amplifier Beach, and all the beaches have now just become an IDF, which is a name for a data room full of PoE network switches. Yeah.
Yeah.
We do still have to have a dedicated room for them with a little air conditioning, mostly because they're super noisy. PoE network switches. They have, again, the fans are somewhere, and the fans we want to keep out of the room. So the room is smaller, there's less air conditioning, but there is still a room somewhere. It's just full of network switches, not dimmers.
And how many, for a space like this, for a space like the Nimoy, how many uh, um, separate physical networks do you put in, or is it a single network with a bunch of VLANs? Like how does something like that look from your perspective?
It usually depends on how involved or not involved the owner's IT group is.
Sure.
I would say that. So usually in production spaces, the owner's IT group wants nothing to do with any part of it. They are like, you have your own thing. Please never call me. I don't even want to know about it. We know it's a data network, but we don't really want to have any part of managing it, which is great for the user side, because when you do have to do what's called converged networks, where you put everything on the building data, you're really at the mercy of the IT folks. If they upgrade the firmware in the switch and then it breaks the settings that you had that you needed for your audio and video, and that happens right before the show, like, you're kind of tanked. So
Yeah.
I always recommend having them sandboxed to just production.
Sure.
And generally in lighting, there's kind of just one network for all of that. There's not a lot of traffic. The bandwidth is pretty low for DMX. We're not doing much heavy lifting there. Audio and video starts to take up a lot of bandwidth, and those are where we see a lot of different VLANs. We'll usually have at least maybe one or two audio VLANs, depending on what format of traffic you're running, Dante or AES or AVB or whatever. We'll usually have a couple of video VLANs, depending on what kind of traffic you're running there. And that might be NDI or SMPTE 2110 or any of the, or proprietary stuff like Crestron NDX, where you can send HDMI over a network.
Sure. Yeah.
Control networks for your touchscreen systems. Clearcom, wireless Clearcom, that's all IP based now. Those also require to be VLAN. The reason is because at the moment, all of them require slightly different network configuration settings. One day that will go away, I hope.
Yeah, right. And so are you think, does that sort of equate to maybe 3 or 4 physical separate networks with copper pulled for 3 or 4 networks, and then a bunch of VLANs within each of those for various purposes? Is that kind of what you're saying?
Generally so. Yeah, it kind of depends on how many ports you need, but yeah, you would usually expect to see, and I like to see, for redundancy reasons, separate physical switches that are running a main and a backup network, in like the case of Dante or something. Within that fabric, doing them as VLANs is nice because it's easier to manage stuff, and there's a lot of tools now for production folks that didn't used to exist. Used to kind of have to be a Cisco programmer to know what the heck was going on. Now there's a lot of production specific switches that allow us lay users of IT systems to understand what's happening. You can just press like Dante VLAN and it does all its things. You're not writing code. So it's become a lot easier than it was 5 years ago.
Well, and that was kind of the next question I was going to ask is how you and I were probably close in time when we were going through to school, and so we were part of that big transition. I was telling a story yesterday at a session here at the conference about how in the 90s we were super excited about how every sound studio was going to be all Firewire all the time, right? And that lasted 3 years, and everybody at the time was like, Ethernet, no one's going to use Ethernet, like Firewire is the thing. And here we are, and Firewire is not a thing, and it's Ethernet everywhere. And so we weren't being taught, I wasn't being taught much about networking. Like, we sort of hacked it out and figured it out. Has that been was that a challenge for you as this transition happened, right? Trying to get up to speed?
Yeah, for sure. And I, like you, also, I don't recall there probably were. I don't remember there being any network classes available for, like, the 100 level person to come in and just get a general understanding.
Sure.
Um, I learned most of that through a VIX, which is the Infocom trade show. There's an industry group for AV folks who has a lot of really great training. So that was where I first started to understand, oh, first of all, we need to know this, because fast forward to today, it's really just a data network that looks like an AV system or a lighting. It's really data. So um,
Yeah.
that's where I really started to learn. And they still have really great offerings, and I think they're free for students. So if you are interested in doing those classes, they're online and they're very, very helpful and very specifically set up for production folks to
Sure.
understand.
That's great. That's great. We've got about 50 minutes left. I want to again prompt folks who are listening and participating remotely to throw some notes in the chat. We could, of course, continue to dig deeper and deeper into any part of this. I know you had a whole lot of different things prepared that you might talk about. Is there a direction you want to go right now, Ian, or should we keep asking more questions about the Nimoy?
Well, I'm always looking forward to the future. And I will say this is a very hard industry to find people to work in. And here's the reason. Over the years, I've decided it's easier to find a theater production person and teach them the architecture rather than the other way around.
Okay.
However, people coming out of school at the moment are generally lacking two things that if they had, they would be gold for theater consultants if you want to work in this industry. So I put together a few bullet points. The second one there, IT and networking knowledge. That's maybe could be the first one. The other one is Revit. Revit has gone from, and if you don't know, Revit is a 3D version of CAD. When I was in school, and maybe you were in school, we learned CAD. I took AutoCAD classes. They were great. I think Jim Lyle, who was the TD at the time, taught them or facilitated them. And it was CAD for production. It was great. I still, to this day, use the same shortcuts I learned at Purdue as I draw CAD stuff. I am horrible at Revit. I'll be the first to say that I have absolutely no clue what's going on. I've tried. I've decided I'm just at a age where it just doesn't, it's not going to go.
I feel
But
like that a lot. I get it.
yeah,
Yeah.
exactly. So I would say if you can, as a student, learn Revit and take some networking classes, you're going to be leaps and bounds ahead of anyone that's going into this industry. And then past that, if you can take any classes in architectural, engineering trades, any of that, it's only going to benefit you in that work as a translator, which is really what you're going to be doing.
Sure.
And your production work is perhaps the most important, because there's very few people that understand how a theater operates physically.
Mm-hmm.
And so that really is, at the end of the day, the most important thing. And that only comes by doing shows, years and years of doing shows and working with different people and learning, from you, Rich, and other of your colleagues about how you do stuff and how does the
Yeah.
building work and why does this thing do that and why do we do it that way. Because pretty much everything that we do in theater is not how anyone else does it. Right? So, like, we're a very weird trade. People are like, why would you have this, or why do you want that? And it's
Mm-hmm.
atypical, but knowing how to do it is super important to make a good building.
Every semester there's a class in Purdue's College of Technology. It's a 300 level class called something like Technology and Culture, or Technology in the World, or something. And the students in that have to go out and sort of look at and engage in different arts and cultural um, um, classes and spaces. And so they come to my theater building, and I do a little hour and a half talk and tour with them. And it is always fascinating when we do a little talk about theater in the house, and then we bring them up on stage, and then they're just looking around. And that's when we start getting the questions like, well, this is weird, and why you do that? And we spent a good 20 minutes just talking about the counterweight system. And
Always.
you were talking earlier today about how there's 1,000 ways to die in a theater. That's the one we focused on, right? Right. I was like, so let's talk about this. Balance beam, right? Totally makes sense. Everything should be safe until here are all the ways in which it's never safe,
Yeah.
right? And then and here's a 30-pound brick, hold it out over a hole for 5 minutes. And you're right. If you're not in it, you don't understand why we do the things the way we do them, and even what those ways are. That's really uh, it's sort of key. I have to imagine that's key to understanding how to develop a new space or a renovated space.
Yeah,
Um, and
very true.
the CAD bit I want to touch base on a little bit. So you learned AutoCAD, is that right?
Yes.
And this is, I don't even know what my question is, other than every time I'm at the USITT conference, it happened in the hallway yesterday. Um, there's a conversation that starts where every different segment of the industry will tell you or tell me as an instructor and as a professor, well, you need to teach this.
Yeah.
And the list of CAD programs that I need to teach,
So long.
everything, right, everything from Vectorworks through AutoCAD, Inventor, SolidWorks,
Hmm.
Fusion 360,
SketchUp.
Revit. Now I need to know, make sure everybody knows BIM. Like how, from your perspective, like Revit is clearly the tool that's most often used in your world.
In our world, in architecture, let's say generally.
Yeah, in architecture. How do there's no way we can either learn or teach all the programs.
Yeah, for sure.
And so, putting you on the spot, how do you reconcile that as an instructor? What do I do? What do I teach?
Yeah, that's a good question. I will say in art history, no one has ever known Revit when they applied for a job at our company
Sure.
because
Okay.
it's generally not taught anywhere unless you're specifically in an architecture school. And even then, if your architecture school focuses more on the art and less on the technology of architecture, you may
Oh,
not even
yeah.
learn Revit there. So we spend a lot of time investing in Revit training for our current people and our new hires. CAD, yeah, CAD is clunky and problematic and difficult and not used anywhere except for in the architecture trade. So if you're, as a student, not planning to go into a trade like this or an engineering related trade, definitely learn not that. Vectorworks or whatever
Mhm.
else people use if you want to be in scenic design or live production. No one uses CAD or Revit in live production. It's way
Yeah,
too complicated and
right.
takes far too much time and it's expensive to buy and there's no reason to even touch it. But if you want to get into architecture,
Uh,
this is what we're using over here, and I get it. There are so many programs to learn, so I feel your
yeah.
pain.
Well, I think as we were talking, like I think there needs to be a conversation here at the Institute, um, USITT about this conversation, because I think there needs to be there's an answer out there about how we make sure folks are prepared to jump into the world of Revit pretty smoothly, even if they don't know Revit or SolidWorks or whatever it is. We haven't focused the energy on it. So I appreciate your answer to that. Um, yeah, I want to be sure we let you have time to cover the other points you wanted to cover. What
That
was
was pretty much it for me. I'm happy to talk about anything more in detail, but we are always hiring, and I know Rick's not on, but I want to give a shout out to him because when I started at Purdue, I was planning to go to New York and Broadway and be operator and an engineer there, and maybe a designer. Although I was always more on the technical side than the art side.
sure.
And at some point, Rick's like, "Have you heard of this thing called consulting?" And I was like, "No, tell me
Sure.
more." And that changed the course of my life, like a good mentor does for you. And so yeah, it's a great trade. I always tell people it's for people who love theater production but hate the hours and chasing the gig. So you're still doing, you're still doing it, but it's 9 to 5. You have benefits and all the things that are nice about an office job, but you're still in theater world. And a lot of people that work for us are still doing live production on the side, so you can kind of keep your feet wet, which I think is great because then you don't lose track of like what's happening in the industry.
Sure, sure. Um, I'm noticing that Tim asked a question in the Q&A. You skipped over AV design, and he wanted to hear a little bit more about the process there. We've got
Oh,
a
sure,
little
sorry.
bit of time. You could talk. I'm assuming about the Nimoy. I'm sorry I didn't see your question earlier, Tim. I had the wrong tab open. That's my fault. I failed, but I think we've got some time to talk about that. So can you talk about the
Sure.
AV process? Yeah.
Yeah, definitely. So again, this comes right back to the programming thing. What are you going to do in here? In this case, they're going to do a lot of live amplified music. So that kind of leads us to thinking about loudspeakers that are able to handle live amplified music. And that's why you see some slightly seemingly outsized or maybe like weirdly sized for the room line arrays hanging in here. If this was a dramatic theater where they were mostly doing, musicals or maybe just playback or something, we probably wouldn't see those. We would see more, traditional trap boxes, maybe some surround speakers for effects and stuff like that. So really the loudspeaker choice heavily depends on what they're going to do in the space. Past that, it's the same discussion as lighting. Everything is IP based, and whether that transport is Dante or AVB or whatever other flavor of audio transport you're going to use, the world is going heavily to IP. Not 100%. There are still other formats out there that are still heavily used. Fiber-based proprietary ones, or a format called MADI is still quite a bit in use. But for the most part, there's going to be some IT, some data network behind everything. We spend a lot of time thinking about loudspeaker placement in all of our spaces because it is pretty much the sole thing that determines how much gain you will get before feedback, how loud you can make the mic before it feeds back. With a vocal mic, like in a space like this, it's less of a consideration. You can turn it up super loud before you're going to feedback SM58 in an array like this. If you have an Omni Lav on the side of your cheek, you can't really turn it up that loud unless you have really, really directional loudspeakers that keep the energy away from the mic and into the audience. So we spend a lot of time thinking about that. I also spend a lot of time thinking about imaging in spaces for audio. In an ideal world, there would be no loudspeakers. Actors would just have really, really loud voices, louder than they already do, and they would just be able to talk at 105 dB, which is impossible. So we have to come up with ways to fake out the audience so that they think that the actor has a really loud voice. In my opinion, especially in musical theater or regular theater, the audience should not realize there are loudspeakers or microphones. It should just sound like it's coming from, the people talking. That requires that the speakers be pretty low. So if you go to any Broadway show, you'll see, the speaker towers start at the stage and go up. Having speakers way up in the air is horrible for imaging, right? So most of our designs, and I'm just looking to see if of the tons that we've done, I don't know if I have any that show this, maybe this one, let's see. Of course, I don't have a picture of exactly the loudspeaker, but I use as a general rule about 10 to 12 feet off the deck for the bottom of the speakers. And that seems to be a pretty good location for maximizing gain before feedback and keeping the imaging to a point that's low. I also am not a fan of a center cluster for all those reasons. It's way up in the air because you have to get out of the way of lighting and everything else. And it kind of has that voice of God feeling, like, there's a sound, there's what's happening clear up there. Now, there are cases where it's useful if you have a balcony and you're shooting straight across and then the imaging still feels about right. But just as a blanket, putting in a center cluster is not something that I usually do. I usually keep them low, left and right, about 12 feet off the deck. So that's the big part there. Video kind of also depends what they're going to do. LED has got real cheap lately to the point that it is competitive with projection, which is kind of bonkers. So LED upstage scrims are cost effective now. They're very low resolution, but you're 40 feet away from it. So a 4 mil LED wall is actually fine and pretty cheap, especially if you compare it to a bright projector with a very short throw lens and a psych. You're in the ballpark, so that has been a huge, huge change. It's the only thing that I'm aware of that is getting cheaper over time. It's very strange. Everything else is this, LED is this, so pretty cool. Let's see, is any other specifics? I know we're almost out of time here, but
I think that's, there's so much we could dig into, right? Like how does the programming impact the selection of the console at the mix position, right? Because mixing for concerts is different than mixing for spoken lectures and all that. I will say, Rick Thomas is here at the conference. We're both referring to Rick Thomas, who was a faculty member at Purdue for many, many years in sound design and technology, who was a mentor for both of us in different ways. I never took any of Rick's sound classes. He mentored me in other ways, but I could hear his all of his teaching about imaging in what you described. And he's taught that same sort of conceptual idea for a long time. So I'll mention to him that you still talk about that the same way. He'll be
Absolutely.
Ian, this was fantastic. Thank you so much for your time.
Sure.
And thank you those of us who've joined us. There's just too much to dig into for us to have even covered all of it, but I appreciate you talking to us about what you've got. Oh, someone threw another question up here. Tim says thank you. And he says they've installed sound systems designed by Shalleck, and they're working on one in Beaverton, Oregon.
Oh yeah, there you go. Okay.
And he says awesome design. So
nice. That's good room.
We'll copy that and put it on the Yelp review page for you. A couple of quick business things that I want to get out of the way. There was a whole question about working with architects and whether they have always listened to theater consultants, whether there's some that do better than others. We'll have you on for another conversation about that. That could probably be a whole hour by itself. In a month, on April 4, we will have with us here at the First Friday of Fusion Studio Heather McAvoy, who's the owner of Heather McAvoy Design, an independent theater consulting and lighting design practice, consulting back to back here for us.
She's great too. She's wonderful.
Oh, great. Okay. And she's the bio I have here in front of me says in 38 years of practice, she's consulted on over 250 projects, including the Thomas Theater at Oregon Shakes, the Mandel Weiss Forum at La Jolla Playhouse, and Portland Center Stage, the Armory, to name a few. So please tune in for that. Registration should go up tomorrow, I believe. And then a couple of other pieces of information that I wanted to share about initiatives at the Fusion Studio. First is that if you are oh my gosh, I totally lost all the things I was going to do here. Sorry. If you are a student or a faculty member at a university with either a graduate or an undergraduate degree or both, the registration link for our annual stage machine design competition is open at centers.purdue.edu/fusion-studio. And you can find more information about that there. The stage machine design competition is an annual competition that will culminates in December with a presentation of prototypes for mechanical machines that solve stage effect problems. So this year's challenge is to create a pedal drop that allows pedals to drop beautifully. That's the term that's used in the prompt, and at an appropriate rate, which is the word that's used, the phrase that's used in the prompt, from 20 feet off the ground, I think, and then has to happen twice in the play, but can't be brought back to the ground to be refilled. So how do you refill it without bringing it to the ground? If you're interested in that competition, there will be live competition events at Purdue in Indiana, University of Connecticut in Connecticut, obviously, Florida State University, and at UNLV. We're trying to spread it around the country so you can participate in any of those. Registration is open now, so check that out. And also registration is open now, and early bird registration ends at the end of this month for our annual symposium on education and entertainment and engineering. You can also find information about that at centers.purdue.edu/fusion-studio. Okay, I said a whole lot of things. Again, Ian, thank you so much. This was great, and we'll connect again soon. Thank you, everybody, and we will see you next time. Thanks, y'all.